So we're going to look at double integrals and using them to find the volume underneath a curve. The PowerPoint is not incredibly useful, but I'm going to go ahead and send that to you anyway in case you don't have it and you maybe want to look through it. I thought what might be more helpful is to actually go through some of the questions that were in the homework at one time. You may have some different questions. You might have a lot of the same questions. And we'll just kind of go through some of the easy ones so that we can see what the process is, and then look at plugging in some of the values to create the double integral, because that's probably the hardest part, and then going through the whole process of creating the integral and actually evaluating it. Double integrals are actually pretty easy to just go ahead and integrate because you're just going to do the integration twice. And you basically just start on the inside and work your way out. So if I have this double integral 0 to 2 and then 0 to 5 of 1 plus 2x plus 2y, I'm going to start with this dy in here and work through this integration with respect to y and just kind of keep the x's constant as if they were just a regular real number. Take care of what I need to take care of and simplify where I can, and then do the integral again. Just a double integral, just integrate twice, but now with respect to x. So if I start with the inside, copy the 0, 2. I'm going to integrate with respect to x, and I don't have, to y, and so this is going to be now a y plus 2xy plus a 2y squared over 2, so just a y squared, and now we're going to go from 0 to 5. When I plug in the 5, I'm going to get a 5 here and a 25 there, so that will combine to a 30. And then when I plug in for the y here, I'm going to get 2 times x times 5, so how about a 10x? Keep wanting to put that y back. And now do what you have been doing for 3 semesters now and integrate with respect to x. So 30x plus 10x squared over 2, so 5x squared, and go from 0 to 2. And easy enough, I get 60 plus 20. All of that for an 80. Not terribly exciting when it's a nice, neat little integral. Here's another one. Sometimes they're not both definite integrals. And when we start to set these up, you can flip-flop this dy and this dx. So you saw over here, this was dy dx, and this one's dx dy. When you flip-flop them, though, you can't just say, switch this integral with this integral. You'll need to rewrite the functions so that when you do the substitutions, you're going to be subbing in for the variables that then cooperate and make it easy to do the next integral. This one's already set up for that, so let's do that first. I'm going to start in here, so I'm just going to copy the 0, 18. This is, if it's a definite integral, these guys out here, these limits are going to just go ahead and be real numbers. That way you can just go ahead and get an actual number when you're done. I'm going to integrate with respect to x, so this is now going to be x squared over 2 plus an xy. And I'm going to have a little bit of a messy integration. I'm going from y over 2 to a 9 dy. Right, so that way when we plug everything into here, all my x's will be gone. I'll just be dealing with some y's now. Let's move this up. And I'm going to write it like this so that I have a bracket. And I'm going to plug in the 9, so I'll have 81 over 2 plus 9y minus, let's see, y squared over 4 over a 2. So how about y squared over 8? Took me a minute. And this one will be a y squared over 2. Which is unfortunate. Let's go ahead and finish this up. Let's see, I have 0 to 18. I'll go ahead and leave him as 81 over 2 plus 9y. Let's see, I can make this, at least one of these guys can match, right? And I'll have a minus 5y squared over an 8, which is not too terrible actually, right? And so we can go now integrate this with respect to y. So I'll have 81 over 2y plus a 9/2 y squared. Let's see, that's going to go up to y to the third over 2, so 5/16 y to the third. And now we're going from 0, yay, to 18. Love 0 because we don't really even have to bother with that. We'll just have to patiently plug this in. 81 over 2 times 18 plus 9 over 2 times 18 squared minus 5/16 times 18 cubed. And I will spare you the time of plugging this in, and you will get out a number. Let's pause it so you don't have to watch that. Okay, so we typed it in, and I did lie to you before. I said 8 times 3 was 16. 8 times 3 is definitely 24, not 16. And then we plug in our 18, and we come down to 972. Plugging it in was the worst part. All right, so, oh, we forgot to sketch. We'll sketch on this one. Same idea. We're going from 1/2 y to the square root of y. And if I want to sketch this, these guys are going to be in terms of x. X equals, x equals. And so if I want to kind of rewrite this, this would be now y equal to 2x, so that's a line. And I would square this, and of course I would have the parabola y equals x squared. There we go. And I have something in between here. So we're going to go from this to this. Got a little like Calc 2 flashbacks, right, of finding the rotated volume of the solid. But now we're going to go from 0 to 4 on the y. So we got 0, 1, 2, 3, 4 out here. And so that would be my sketch. Now what we can do is find the area under, or the volume underneath of this. I'm going to get rid of this piece right here. And integrate with respect to x, so 0, 4. And I have now y squared. He kind of acts like my constant, and this is going to be y to x to the third over 3. Go from 1/2 y to the square root of y, and then eventually dy. A little messy. All right, let's plug in y. I have y squared times y, the square root of y cubed. So I'll have y squared, y square root of y over 3. Got a lot of y's. Minus y squared times 1/8 y cubed over 3. 0 to 4. Oops, too fast. Eventually 0 to 4. dy. All right, let's see if we can make this a little bit less scary. I have y squared times another y. So that is going to be y cubed. And this is y to the half. And when we multiply these guys, we're going to add them. So how about 3.5? And I guess we can go with 7/2. Y to the 7/2 over 3. And now I have y to the 5th up top, and I'm going to kick that 8 down to here, so 24, not 16. And now we can integrate this with respect to y, and it doesn't look quite as bad. Okay. Got this 1/3. I'll deal with the rest in a minute. So this becomes y to the 9/2 over 9/2. So let's go ahead and flip that right now. Minus y to the 6 over 6, and then I have this 1 over the 24. 0, yay, again to 4. Not a whole lot of cleanup that we have here. This just got bigger. I have 2y to the 9/2 over 27 minus y to the 6 times whatever 24 times 6 is 144 from 0 to 4. Handy calculator. Plug in my 4. I did it in 2 steps so that I have 2 times 4 to the 4.5, right? My 9/2 divide by 27. I got that part. And then I subtracted the 4 to the 6 divided by 144, changed them back to a fraction. 256 over 27. Terrible. But the answer that we're looking for. Okay, so it's ugly numbers, but not usually too terrible to set up. If they give you vertices, life is actually a little bit easier. So I have 0, 0 to 0, 9, 5, 9, 0, 9. It helps if you know how to plot a point the right way. To 5, 0. And then, of course, 5, 9. That's what we have, an alleged rectangle. Don't look very much like a rectangle the way I drew it. They said, all right, find that area underneath this, the volume underneath this with xy. So xy is going to go into here. Now they have us do it 2 different ways. This one is not going to be very interesting because if I'm talking about in terms of x, they gave us these hard cutoffs, if you will. So x is going from 0 to 5, this x, and then the y is going from 0 to 9. And if we just go the other way, then we would just swap those 2. Neither one is really easier to do than the other since they're both definite integrals. So I guess I'll just go ahead and do this first one right here. So 0 to 9 I'll keep, and I'm going to integrate with respect to x first. So this is going to stay a y, and now I got x squared over 2 from 0 to 5. Plug in the 5, I get 25 over 2y dy. And now I can say y squared over 2, so 25y squared over 4 from 0 to 9. Plug in the 9. 25 times 81 over 4. Don't worry about the 0, right? Because it's just going to wipe this piece out here. This one's short enough to just go ahead and do. And I'm sure they probably want it as a fraction. 2025 over 4. Either way, you would have gotten the same one. This one's a little different in that when you swap the order, they're not going to, it's not just going to be, because it's not a definite integral on both sides, like with a x equals this number and then x equals this number. They're going to look a little different when you change these around. And I think that the picture actually helps. On the question, it didn't have the picture. It was actually in the answer key, and this is an 8 here. And so if we're looking at it from this, I have y equals x. So of course, where's that? Right here. And then you got your y equals 8x up here. And I'm going from the 1 to the 8 on the x. So if we're looking at it over here, that they want to start at the 1, and then we want to talk about the dx first. Then when I do my substitution for the x, I want to be able to put in y's because then I need to integrate with respect to y. So I'm going from the 1 to whatever it says over here for my y equals x, but I don't want to use the x because if I plug in another x, I have to deal with him when I have the dy. So we're going to change, say, from 1 to y. And then for the next part, I'm going from 1 up. And so with my x's, I'm going from just the 1 to the 8 for my y's. Over here, we'll have to go from this piece right here. This would be the y over the 8. That is my x value over there. And we want to go up to the 8 over here. So we're going from this one to this. And then we have the 8 that we're working with, but we're heading up to a number. And so we're going to have 8 up to wherever we peak out up here, which is at the 8x. So this guy is going to have to be a 64. Not nice. 2 double integrals. It would be a lot easier if we went the other way and dealt with the dy first, because I have both of these written in terms of the y, right? These are really nice and neat. So I can go from the x to the 8x for my y values. And then for my x's, I already have them defined. That is just 1 to 8. So this is going to be the easier one to integrate. All right, so let's see if we can if we can remember how to do this. I'm integrating with respects to y. So this is basically just a number. So I can kind of think about him as like 5 plus y squared. And so if this is just some kind of a number, and I say let u be, I'm just going to write like this so it doesn't get confusing, plus y squared, then du is a 2y dy. Oh, okay, so then I need a 2 in here and a half out. I'll squeeze him in right there. And I basically have the ln, right? So now I have 1 to 8, 1/2 the ln of x squared plus y squared. Oh, goodness, from 8 to x, from x to 8x, and then eventually we'll have to deal with the dx. Okie dokie, so let's see, 1, 8, I'm going to kick this guy back out here because we have enough to deal with. Plug in the 8x, and so I'll have ln of, now when I square this, it will be a 64x squared. So now ln is 65x squared minus ln, plug in just the x, so how about an x squared? Oh, 2x squared, because I got 2 of those guys in there. Yay. dx. Well, we could split them up, but it's not really necessary. Oh, yes, we can put them together, can't we? Because this would be 1/2. Now it's going to be 65x squared over 2x squared, or ln of 65 over 2 dx, which is just a number. So 1/2 ln, where the heck do I want to put that x? 65 over 2 times x, this mess, from 1 to 8. Ooh, like this. Okay. 1/2. Are you having fun yet? 8 ln 65 over 2 minus just another ln of 65 over 2. And once again, we have ones that we can put together. Bring this up so he would be like an 8 up here. So then when we put him together, we would get 1/2 ln 65 over 2 to the 7th. I suppose you could bring it back down, but I don't think that's really necessary. You know, you could say 7 over 2 ln 65 over 2. I mean, really, either way, it looks terrible. So, welcome to Calc 3, where the answer to every question is horrendous. Okay, so now they don't even give you anything. They give you the picture, and they say, figure it out. He's the piece that's going to go on the inside, right? Because he's my function of x, y. So I have double integral something like this, and I'm either going to do a dy dx or dx dy. And if I had to guess, I would guess the dy maybe, because we already have, I mean, we don't have any x's in there, so it's really not too terrible. And so my dy's, I am going from 0 up to y equals 2. And then for my dx's, I'm going from 0 to 4 on the x. And that wasn't so bad at all. 0 to 4, 7y plus a 2y squared over 2, so just y squared, from 0 to 2. Plug that in, we will get 14 plus 4, 18 of a dx. How nice. 18x from 0 to 4. Well, whatever 18 times 4 is. That's what you're looking for. Let's look at another one. I got 36 minus y squared. So, of course, he's going to go on the inside. And I have these two. 36 minus y squared. And the y is going, okay, so now this one's a little different because my x isn't stopping, like it's not going from like 0 to 5. It's not like this one where I kind of have this nice little rectangular base. So on this one, we are probably going to do the dx first and then do the dy, because the dy is going from 0 to 6. And so now he's definitely starting at 0, but he's going up to the y for my x's. So let's go ahead and integrate this with respect to x. So how about 36x minus y squared x, and now go from 0 to y. So that way we'll only be dealing with y's on the next part. 0 to 6. And there's, let's see, zeros will go wipe everything else out. So I really just have to worry about the y. 36y minus y cubed. Oops, dy. 36y squared over 2, also known as 18y squared. This will be minus y to the 4 over 4, 0 to 6. Plug in 6's. You could do that without me. You don't need me to plug in 6's for you. So it's a little bit different when your base is not square or rectangular. That's when you're going to have to say, who has the nice hard line that I won't need to worry about swapping out variables? Oh, last one. Find the average value. Okay, so you're going to do the same thing. Average value formula, here we go, is this. Integrate, and then you just subtract with that 1 over a, where a is the area of R. And so let's see, can I bring that over there? Perhaps. We'll go, let's stick him right here, just like that. Well, we got a square. 0, 0, 2, 0. Yay for plotting the point the right way. 2, 2. 0, 2. 0, 2. Area 4. Easy enough, right? So I'm going to have 1/4 x squared plus y squared. And since this one could really go either direction because I just have hard stops, we're going 0 to 2 on both. Either one really is fine. I'll go dx dy. So 1/4, 0 to 2. So this is dx, so I need to integrate with respect to x. I'll have x squared. No. X cubed over 3 plus y squared x from 0 to 2. Plug in my 2, 8/3 plus 2y squared dy. I guess we don't need to write that now because we know how to do the rest of this. 8/3 y plus 2y cubed over 3, which is pretty much as good as it's going to look, and that goes from 0 to 2. So I have 1/4, 16/3. Oh goodness, 2 times 2 times 2 is an 8. Oh, look at that, another 16/3. 1/4 times 32 over 3, which is 8/3. And hopefully that helped. And if you think of anything, you know where to find, actually, you may not know where to find me. I'm on the first floor now and no longer on the third floor. And I'm free on Wednesdays from 12 to 1:30. But you can always shoot me an email too. Talk to you soon.